Right, now the next session is on diesel cycles. Now let's we first compare the Octo cycle and the diesel cycle, basically the petrol engine and the diesel engine, right? Now I want you to go to the internet, maybe YouTube or somewhere, and try to find out what are the differences between petrol engine and the diesel engine, right? I will be quickly saying few things here, but it is better if you search it on your own, and there are a lot of like animation type videos in the YouTube, so you will get a better understanding between the two type of engines, right? So let's we talk about the main differences. So normally a petrol engine, you have a spark plug to ignite the air fuel mixture, right? Whereas you don't have spark plugs or any kind of ignition system. What will happen in the diesel engine, once you compress the air, after that means when the piston goes to the top dead center, so at that time you have fuel injector to inject the fuel, right? While that injecting, it will self ignite, right? Self ignite, and then it will create the power stroke. Whereas the petrol engine, you have a spark plug to ignite the mixture. And also what is compressing in the gasoline engine or the petrol engine is the air fuel mixture. It is the mixture that compress, and the diesel engine, it is only the air that compress, right? And in petrol engine, you should make that mixture prior to entering the cylinder. That means in some of the engine you have injectors that inject the fuel into the manifold, input manifold we call, that means the part that comes to the cylinder we call input manifold. You are injecting petrol into the input manifold, or sometimes some engine have something called carburetors, right? You know the carburetors, normally most of the bicycle, three-wheelers and small type of engines and small hand tool type of engine, small engine, they have something called carburetor. What the carburetor do is mix the fuel with the air, right? And that is completely apart, different from the diesel engine. What diesel engine they do, they are not mixing anything, they are compressing only the air. Once you compress the air, you are injecting directly into the system, into the cylinder itself. Now in petrol engine, we are normally not directly injecting into the cylinder, but there are engine direct injection petrol engines are there, but normally most of the time you are injecting into inlet manifold. That's mean most of the cars nowadays we are having injecting into the inlet manifold. So the idea, what is takeaway here is petrol engine compress the air fuel mixture and use a spark plug to ignite the mixture, whereas diesel engine, they are only compressing the air once it in the top dead center. That means it's achieve the higher temperature. Once you compressing, you know, once you compressing the air, temperature will be increased. Once it goes to top dead center, you have fuel injector to inject the fuel. While in injecting, it will self ignite, and then it make the power stroke, right? So if we compare the both cycles, right, Octo cycle and diesel cycle, now these part are common, right? So you have isentropic expansion, that means power stroke, right? Isentropic expansion, then constant volume heat rejection, and then isentropic compression. All these three, 1, 2 and 3, these are common to the Octo cycle as well. What is difference is you have a Q in heat addition. So in the Octo cycle you have something like this, goes like this, right? In a straight up, where you have constant volume heat addition process like this, right? Constant volume heat addition. But the diesel cycle, we have constant pressure heat addition process, right? So P is constant, right? P is constant. Then we have isentropic expansion, constant volume heat rejection, isentropic compression, right? So only difference is constant pressure heat addition in the diesel cycle, constant volume heat addition in the Octo cycle, right? So this is the PV diagram and this is the TS diagram, right? So you have isentropic compression, entropy is constant, then constant pressure heat addition, isentropic expansion, then constant volume heat rejection, right? That is the main difference. And if you work on this on the analysis, right, so in the diesel cycle the heat addition takes place at constant pressure. Accordingly, process 2-3 involve both work and heat. So the process 2-3, that means the heat addition process, involve heat and work both, right? Therefore, if we can calculate the work here, right? The amount of work, if you remember, work is equal to P delta V, right? Integrating in from 2 to 3, P delta V, and we can consider that one P2 because P2 is the constant pressure, P2, then delta V, V3 minus V2, right? Then and also we can the heat added in the process 2-3 can be found by applying the closed system energy balance. That means if you remember the first law of thermodynamics, right? So we can consider the internal energy change equal to Q minus W, right? Then with that we can equate this one by substituting to W, right? U3 minus U2, Q, that means the heat transfer, Q equal to U3 minus U2 plus P delta V, right? Then we can arrange this like this and it become H3 minus H2. So if you remember in the Octo cycle, we work with U values, internal energy. All the things are, that means 1, 2, 3, 4, all the 4 points we consider U values. But here it is different. 3 and 2 values we normally using H values, that means enthalpy values. Other 2 points, that means 1 and 4 we normally getting using U values, right? That means internal energy value, U1, that's 1 and 4 internal energy, 2 and 3 enthalpy values, right? That is what how we are working. Why enthalpy? Because it involve work as well, right? Therefore I think you remember H equal to U plus PV, right? That is the definition for the enthalpy. Therefore we can consider this one as H3, this one as H2, right? That's how it become H here, okay? Enthalpy rather than the internal energy value, okay? Then so with that after that we can calculate we can formulate this equation for neta. So neta equal to W cycle, W net divided by Q in, right? Then we can consider that one W cycle or W net equal to Q in minus Q out, that Q in minus Q out. Therefore we can consider Q in goes 1 minus Q out divided by Q in. So this is how there, and then we can consider that one, right? 1 minus U4 into U1 divided by U3 H3 minus H2, right? Then after that we can construct this equation. Now we are not going to derive this one, right? So you don't need to derive this one. The neta equal 1 minus 1 over Rk. Now I think you are familiar with this term, right? This term, because it is the same term we get for the octocycle as well. 1 minus Rk minus 1, same thing, right here. And then we have an additional term in Rc, right? Now the Rc is equal to V3 divided by V2. We call it as the cutoff ratio, right? V3 divided by V2 called as cutoff ratio, right? So again all these are constant. Now if you for a particular engine, Rc and Rk, R value and Rc values are constant, right? So if we assume the Rc is a constant, right, it is then again same way we can predict the efficiency values, right? If you remember the last time octocycle, we derive 1 minus 1 over Rk minus 1, this part neta equals that one, and also we discuss how the compression ratio affect the efficiency. The same thing goes here, only difference is we have different Rc values, right? Now for octocycle, Rc value is equal to 1 because you know in the constant pressure V3 equals to V2 if you are in octocycle. Therefore Rc become 1 for octocycle. For diesel cycle you have different Rc values, right? In So the thing is, if you consider a same compression ratio, same engine with diesel engine and petrol engine which has same compression ratio, right, let's say 10, normally octo engine or the petrol engine has much higher efficiencies compared to diesel engine for a same compression ratio. If the both engine has same compression ratio, then petrol engine gives much higher efficiency compared to diesel engines. But in normal situation the things are different, because diesel engines are much more efficient compared to petrol engine, because they can achieve much higher compression ratios. I think we have discussed that one in the octocycle as well, right? So diesel engine has much higher efficiencies. Okay. Right, so the next thing is this question. So I want you to pause the video and try to work in your own, right? Try to work it on your own, and the next video we will discuss how to solve this question, right? Okay.